Magnusson, and I'm a PhD student at Linköping University in Sweden, where I work at the AI department together with my advisor, Patrick Doherty. And the title of the talk, well, the talk is about a paper called Temporal Action Logic Question Answering in an Analogy Game. But I'll concentrate on what I think is the message of the paper. And then I'll have the obligatory video demonstration. So the paper is about applying logic to computer games. And I believe that logic will be fundamentally important in building an AGI. And you might question why I believe that. Well, the key aspect of an AGI is that it has to be applicable to any type of problem. And logic has a number of features that makes it seem suitable. For example, it has at least these three features that I listed. If we express knowledge in logical form, then we can apply theorem proving. And theorem proving is an entirely general algorithm, can be applied to any problem. And logic is not domain dependent, so we can try to express any type of knowledge in logic. And finally, we want the AGI to learn from books, for example, written in natural language. So you can potentially translate between natural language and logic and thereby learn from books, for example. And if you think, this sounds like logic is the solution to all our problems, and it sounds a little bit too easy to be true. And you're probably right. If we try to put this vision into practice, we'll find that there are some stumbling blocks.
You can just keep going.
Yeah. There are some stumbling blocks when you try to do this in practice. And these are what I'll talk about next. So first, when we are considering theorem proving, if we view theorem proving as an entirely black box algorithm, and we just put the things in and hope that the solution will pop out, that doesn't really work. And I know it doesn't really work because that's the first thing I tried. And I formalized common sense reasoning problems and put them in an off-the-shelf theorem prover. And the performance was simply not acceptable. So what I do now instead is I use a natural deduction theorem prover. And this makes it very easy to add special purpose rules. So for example, I have this temporal action logic where time is the integers. And then I have integrated constraint solvers. And this makes reasoning about time, this narrow domain, reasonably efficient. But it's still a general purpose algorithm, so whenever the special purpose rules fail, you can always fall back on the more general algorithms. And given that logic is universally applicable, well, we might be able to formalize a giant knowledge base with all the things an AGI will need to know. But doing so will probably be extremely difficult and take decades. So what do we do until then, when we have a half-finished knowledge base? What's a half-finished knowledge base useful for? Well, I believe that these computer game applications, they provide one application where you can actually use a knowledge base that is not fully developed, but still have it do useful things. And I believe that because there are so many different kinds of games, some of them are extremely simple, where even today's technologies will be enough to do useful things, while others are these giant virtual worlds where we will need a lot of common sense reasoning to do anything useful. And finally, the translation into natural language. While it's possible in principle, no one has yet been able to create a general enough, a grammar with enough coverage to make it useful. And here I think there is a way to maybe circumvent this stumbling block. So what I have in my application is an interactive parser. So it works somewhat like this T9 system that you might have in your cell phones, but instead of suggesting word completions, it suggests sentence completions. So So what happens is that it guides the input into a sentence that is guaranteed to parse. So you get around this problem where half of your sentences will just result in parse that will be really annoying. So let's look at a simple prototype game demonstration that makes use of these very general technologies in a quite limited way. The guy running is a human-controlled avatar, and he meets up with a virtual character. And you see at the bottom of the screen, you see the interactive parser guiding sentences, and it uses a really simple grammar with a bidirectional chart parser. It makes it possible to use the same grammar for both parsing and generating the replies to the questions. And the questions are answered using this natural deduction theorem proving. And as you see, we don't make close to assumptions, so there is this pervasive ignorance about the world. Now let's explore some more of this virtual environment. And as we do this, we find this other game character. And this guy is actually proactive. He takes the initiative in the dialogue by asking a question. And we happen to know this information he's asking about because we just visited this caper character, and we know he owns the X. And we also know where he is. Of course, distances are measured in screens rather than miles in this world. And the game character, he can take this new information that we provided to him and use it to carry out his plan. His goal is to obtain some lumber. He needs some lumber. And part of his plan was to buy an axe. And as we see, this plan involves several agents, at least 2 agents by now. And as a demonstration of the generality of the technique, the plan he found was found using the same theorem proof as is used to answer the questions. So here we're asking a question that requires memory of past events that have happened. But he still hasn't satisfied his goal of obtaining this number. So we leave him for a while, and he'll carry on his plan, which involves chopping down the tree to get some lumber. And the reason he decided to chop down the tree was he used his action logic. So he knows about the effects of action, and he can reason with those using the theorem proving to come up with complex plans. Now let's try to buy the lumber from this character. We can do that by issuing simple commands, not just questions. And our avatar will form a very simple plan to carry out this command. And we're basically free to do anything we want in this environment, but let's go back to the other character and try to sell the lumber and maybe make some money in the process. So this character, he actually charges 6 gold instead of 3, which our avatar detects as an inconsistency because he thought the price was 3 gold. But it doesn't matter, if we sell it to him, we will get the 6 gold and we will make money in the process. So perhaps by doing this, we have solved a simple puzzle in some future video game. So what I'm saying here is not that we have solved all these stumbling blocks. What we have is figured out a couple of techniques to get around these stumbling blocks to make and chosen this application, computer games, to have one possible avenue of incremental progress towards a logical API system. Thank you.